one of you. So today we are back with chemistry chapter 1 revisions, class 12. Okay, the first topic we are going to discuss today is the radius ratio. So what is the radius ratio? It is defined as the ratio of the radius of cation to the radius of anion. So mathematically we can express it in this way. This one will be the mathematical expressions. Okay, this is our mathematical expressions. You should remember it. Okay, so what is that? Radius ratio equals to radius of cations. That means the radius of the positive part by radius of anion, that is the negative part. Okay, radius r positive, radius r negative, means the radius of positive by radius of negative. That is called as what? Radius ratio. Dear students, if you are able to get the radius ratio, with the help of this radius ratio you will be able to say what kind of structures the particular compound has, what is the coordination number that particular compound has. Okay, got it? After doing this we will definitely do some questions based on this, and I will show you how to find out the coordination number using the radius ratios. This kind of questions, even it comes in the JEE and NEET examinations also, so it's very important. Okay, got it? Okay, fine. Now look at the table: radius ratio, coordination number, structure, examples. So if the radius ratios, when we divide radius of cation by anion, if we get something in between 0.155 to 0.225, in between this if we get, then that particular compound's coordination number will be 3. Structure will be trigonal planar, and examples of that kind of structures, examples are B2O2. Okay, got it? Now if we find out the radius ratio and we got something between 0.225 to 0.414, if we got something in between this, then the coordination number will be how much? 4. What will be the structure? Tetrahedrals. And what is the example of it? Zns, CuCl, CuBr, CuI, BAS, HGS. All these, they will have which kind of structure? Tetrahedral. And what will be their coordination number? 4, and their radius ratio falls in this category. Okay, got it? Okay, next, radius ratios in the range of 0.414 to 0.732. In this range, whichever radius ratio comes, they will have coordination number 6. And what will be the structure? Octahedral. And example is NaCl, MgO, NaBr, CaS, CaO. Okay, so these are some examples. Examples also you should remember, structure also, coordination number also, radius ratio also. You should remember it, dear student, because it is very important. Even in the board examinations, it comes for choose the correct or short questions. Okay. Fourth one, if the radius ratios after dividing, if you get something between 0.732 to 1, then the coordination number of that particular compound will be what? 8, and structures will be what? Cubic. And what are the examples? CSCl, cesium chloride, cesium bromide, tellurium bromide, and ammonium bromide. So these are some examples. Okay, dear students, hope you have understood. Very simple it is. You can pause the video and you can take down the notes. Okay, got it? Okay, so we are going to do questions on radius ratios. I have written as a revision here so that we can take a help. We can take a help how to use this table. We will come to know in these questions. Okay, so what is the questions? The radius of N positive ion is 95 picometers. Okay, they will be giving you like this, and that of Cl ions is 181 picometers. Predict the coordination number of Na positive. So these questions can be asked for 2 marks, can be asked for 1 mark also. Okay, and in the NEET and all, they used to ask it for 4 marks. Okay, so try to understand. Okay, let us try to understand. This question is very simple. So we know it is given. What are the things given here? Given is, we will write the given portions. The given portions is here given. So given here Na positive, it is given 95 picometer. Fine. Next, Cl negative, it is given what? 181 picometer. So this one is nothing but Na positive is what? Na positive is nothing but R positive, radius of R positive and negative. This is the radius of a cation and this is the radius of a anion. So we know the ratio, radius ratio का formula we know, R positive by R negative. So R positive is how much? 95. R negative is how much? 181. Okay. Picometer it will be cancelled. Picometer and then picometer it will be cancelled. Now we have to find it out this one. Okay. Got it? So how to go about? We have to divide it. Okay. So let's divide and let us check in which range it falls. From there we will be knowing if you know the tables. Okay. So 181 and 95 it can go. So point here 0. So it will be going how many times? If we take it, suppose let's see that it is 4 times. Yeah, 4 times it will be going. 4 1s are 4, 4 8s are 32, 4 7. Okay. Okay. Fine. 5 times 5 1 5 40 5 9. Okay, 5 times it can go. So let's go take it by 5. 5 equals to 5 40 and 5 9. So it will come 10 5 and there it will be how much? 4. Okay. So this decimal is there, 1 0 will come. So how many times it will be going? 2 times, then 16, 3 times 3 24 and 3 5. So 2 times it will be going. Got it? So it will be 2 16 to 3. So it will be 8 and then it will be 14. Again it will be 8. So 0. Then now how many times it will be going? Now it will be going 6 5 5 at the 5 was the 5 40 5 9 4 times. So it will be going 4 times 4 32 4 7. So we are getting what? Radius ratio. How much we are getting? 0.24. We are getting 0.524. So dear students, why I told you to memorize the table which I have given you earlier, because see this 0.524 it falls in this range or not? 0.412 to 0.732 it falls in this range. That means what will be the coordination number of Na positive? So the coordination number of Na positive we will write here. Since 0.524 falls in the range of 0.414 to 0.732, okay, hence the coordination number of Na positive is 6. Got it? This is how we will be finding out the coordination numbers with the help of what? Radius of cation and anion. And what will be the structure? The structure here it will be, structure equals to octahedral. Okay dear students, so for that reasons I told you to learn this table properly. Okay, so now you can take it down. So I hope you have understood how to find it out. Okay, and pause the video and you can take down. Okay dear students, so this table is very important. Every year you will get a questions in the competitive exam as well as in your board examination. So that's why I thought of making these tables for you so that you can take it down. Okay, so in this table we are going to study about the compounds, okay, and the similar kind of coordination numbers which others compounds they have similar kind of coordination numbers, similar kind of descriptions, all those things we are going to study here. And okay, so the first example we have considered is what? NaCl. So NaCl, in NaCl how will be the arrangement? So CCP arrangement for Cl. Cl will be occupying what? CCP arrangement. Okay, got it. And Na positive will be present in all the octahedral sites. in this. Okay, so they used to ask which one is present where, so you have to remember this description. Cl negative will be present at CCP, will have CCP arrangement, whereas a sodium Na positive will have a octahedral arrangement. Okay, will occupy octahedral sites. Next, what will be the coordination number? So coordination number of Na positive is 6 and Cl negative is 6. This question has been asked 2 or 3 times in your board examinations, okay, state board as well as in CBSE. Other examples other examples which has the same kind of coordination numbers and same kind of descriptions are Li, Na, K, okay, plus AgCl, AgBr, MgO, CaO. So these all compounds, they have like this kind of structures, okay, like this kind of coordination number and like this kind of arrangement. I hope you understood. Next, moving on to second type, that is Zns Zinc Blend. So zinc blend also, you will see that CCP arrangement for S2 negative and Zn2 positive will be present in alternate tetrahedral sites. Okay, here Zn2 positive is present in alternate tetrahedral sites. And what is the coordination number of Zn2 positive? 4, and S2 negative is 4. So coordination number, very important it is, you have to remember it. Other compounds which have the same kind of arrangement, coordination numbers are what? BES, CuCl, CuBr, Cui. Okay, now coming to the third one, CSCl, cesium chloride. So cesium chloride, you will see that chlorine will be having a simple cubic arrangement, and CS, they will occupy the cubic sites. Okay, so coordination number, CS positive coordination number will be 8 and Cl negative coordination number will be 8. So other examples which has same kind of description, same coordination number are CSBr, CSI, TLCl, TLBr. Okay, now fourth one, CaF2. This question was asked in the NEET examination. Okay, which year it is asked, I am a little bit doubtful about the years, but I think it is 13, 14 like that. In that year it is asked in the NEET examinations, the coordination number. So CaF2, what is the arrangement? CCP arrangement for Ca2 positive and F negative occupy tetrahedral sites. And what is the coordination number? Ca2 positive coordination number is 8, F negative coordination number is 4. And similar type of compounds which has the same coordination number and descriptions are SrF2, BaF2, CaF2, CdF2. Okay, the last one is what? Na2O. In Na2O, you will see that CCP arrangement is of O2 negative. O2 negative, it has CCP arrangement, and Na positive occupies the tetrahedral sites. Next, what is the coordination number? Na positive coordination number here will be 4, and here Na O2 negative coordination number will be 8. And similar kind of examples are L2O, K2S. Okay, so this table, dear students, again I'm telling you, very important. All of you can pause the video and take down the table. Okay, okay, dear students, very important formula of this chapters we are going to derive now. Okay, it comes sometimes they ask these derivations also for 2 marks in the board examinations. Okay, it's very simple. Let us try to understand. We have considered a unit cell. This is a unit cell. The edge of this unit cells is how much? A. So we have written, consider a unit cells of edge length A. Written this one. Then if you can see it is like a cube only. So unit cell means all the sides will be equal. So volume of the unit cell will be equals to what? Side of a cube. Volume of a cube is equal to side cube. So side is A, so A cube. Okay, this point is clear. Okay, next is what? Density. Density is represented by a symbol called rho. Rho is equals to mass by volume. So we have written mass by volume. We know that, okay, we know mass of a unit cells. Okay, this formula, we know mass of a unit cell is equals to what? Number of unit atoms of unit cell into mass of each atoms. So number of atoms here in unit cells, we are considering it to be number of atoms to be Z, and mass of the each unit cells, each atom we are considering it to be M. So now first of all we have found out mass of the atom in unit cells. M equals to atomic mass by Avogadro's number. So it is equals to M by capital A. Atomic mass is represented by capital M. Avogadro's number, it is represented by Na. So this value will substitute here in place of small n, Z into capital M by Na. Now this value and mass, in place of mass we will substitute this value, and volume is what? A cube. So rho equals to Z into Na by A cube. So this Na, it will be coming down. This is called Avogadro's constant. So finally you got the formula for density. Rho is equals to Z into M by A cube into Na. Its unit, the density unit is gram per centimeter cube, and Na value is 0.2 into 10 to the power 23 mole. These values and all you have to remember it, okay, because we are going to now learn into the numericals, which is very important from these chapters. Okay, dear students. Okay, you can pause the video and take down the students. So now we'll do some questions. Okay, this is the questions which we are going to do now. It is from 2019. These questions came in 2019, 2016 it came. Okay, NBSE for 3 marks. Got it? So we are going to do the questions. Only the thing is a little bit in NBSE we are allowing the calculators, simple calculator. So it's very simple. It is calculation is little lengthy, but it is simple. So what is the questions? Question is a unit cell. Okay, a unit cell of an element, a unit cell of an element of atomic mass 108 and density 10.5 gram per centimeter cube is a cube, okay, with edge length 409 picometer. Find the structure of the crystal. Find the structure of the crystal. Given Na equals to 6.02 into 10 to the power 23 per mole. So this is the questions, and it was asked for 3 marks. Okay. Okay. So it's very simple. Let us try to do it. The formula which we have derived, it is based on that only. So first of all, we'll write here what are the things given. Given atomic mass, it's given. Atomic mass is basically represented by M. So it is given M equals to 108. Okay. Then density is given. Density is rho equals to 10.5 gram per centimeter cube. Fine. Then the edge length is given. A equals to 0.9 picometer. So this one will change into centimeter because density is somewhere it's given in centimeter. So 0.9 into 10 to the power minus 10 picometer. Okay. Oh, sorry, centimeter. Got it? Okay, fine. Now they are telling us to find out the value of Z structure. With Z we can say what kind of structure it has. So we have the formula. What is the formula we have? Z equals to rho equal to Z into M by N A into A cube. So first of all, what we will do, we will rearrange the formula because we want to find out Z. So Z will be equals to Na, this one cross multiplied, okay, this way. So Na into A cube into rho by M. This is the formula for Z. Okay, so Na value what we have here, 6.02 into 10 to the power 23 mole. Okay, fine. So we have written it, or unit you just write it at the last. Okay, so write it this way: Na cube. So 0.0 into 4.0 into 4.0, and there are how many? 10 to the power 10. So 3 times it will be how much? 10 to the power minus 30. Rho is how much? 10 to the power 5 by, what is the value of m? We have 108. Okay, so we have written that. Okay, fine. Z equals to, first of all you multiply all this, so it will, and you multiply this one and this one, 6.02 and 0.5, 10.5. so if you multiply this one, 6.02 and 10.5, then you will get 63.21 into, you multiply all this, so all this if you multiply, you will be getting 6841 7,929, and see here 10 to the power 23, here 10 to the power minus 30, so it will be 10 to the power minus 7. Okay, 10 to the power minus 7, got it, divided by 108. Now when you divide and multiply it, okay, then you will be getting it. Okay, when you multiply and divide, you will get around okay, you will be getting around 4.004. so this much you are getting, that means 4.0 means we are just, which is approximately 4. So the value of Z we are getting how much? 4. And if the value of Z is 4, which kind of structure it is? We have already studied the number of atom in FCC is 4, BCC is 2, and simple cubic is 1. So this is Z equals to 4, hence, right, hence it has FCC structure. So for doing these questions, you are getting how many marks, dear students? 3 marks. You are getting, this question is repeated twice in your examinations. Okay, so you can pause the video and note it down. Okay, so fine. Now we are going to do questions which is asked in 2018 for how many marks? For 3 marks. Okay, so these questions we are going to do. What does the question say? Calculate the value of Avogadro's, okay, calculate the value of Avogadro's number. So we are asked to find out the Avogadro's number value. Okay, the density of NaCl equals to, it is given 2.165 gram per centimeter cube. Okay, distance between Na positive and Cl negative is 281 picometer. Okay, molar mass it is given, molar mass of NaCl 58.5 gram per mole. Okay, so these are the informations given in these questions, and now we are asked to find out the value of Na. Got it, dear students? So first of all we will write let Avogadro's number equals to Na. Okay, we are assuming that let the Avogadro's number be Na. So what is given here? Density is given, so rho equals to 2.165 gram per centimeter cube. Molar mass capital M is given 58.5 gram per mole. Okay, so distance, that is age, we need to find it out. Okay, and yeah, and anything more information it is given here. Any more informations? The more informations here we will be getting is calculate the value of density. Okay, and a positive and CL negative. Okay, fine. So after that, what we will be doing here, we have written here rho M, we have written. Now we will try to find out the molar mass. Okay, molar mass we have already got, then rho we have already got. Edge length we are going to find out. Edge length is equals to, what it will be the edge length? Edge length is twice into distance. Edge length is equals to twice the distance between the ions. So 2 into, what is the ions here? Ions, between the ions distance is 281. So it will be 264 picometer. Which one if you change 264 into 10 to the power minus 10 centimeter. Now, and here Z will be equals to 4. Got it there, students? Now we will use the formula. Rho equals to 2.165, sorry, rho equals to Z into M by Na into A cube. This is the formula. We are asked to find Na, so we'll write here Na. This one you bring this side, and this one you take it there. So Na equals to Z into M by rho into A cube. So Z ka value for NaCl is 4, and M ka value it is given 58.5 gram per mole. Another one, rho ka value, that is density 2.165 gram per centimeter cube into A cube. A cube ka value you have to write it 4 into 10 to the power minus 10. Here it will be what? Centimeter cube, and this one cube. So okay, so this one and this one cancel, gram cancel. So what will be left? Mole will be left. So if you calculate properly, then you will be getting here. Okay, just a minute, I think 22415 it will be. Sorry dear students, it is 5 here, so it will be 562. So if you calculate, you will get the value of Na equals to 6.02 into 10 to the power 23 per mole. Got it? 6.009 we are getting. 6.009 into 10 to the power 23 per mole. So this is how you will be calculating the value of Na. Okay dear students? Okay, so these questions we have done, question paper of question 2019-2018, and these are some basic level questions which used to come in your examinations, which you need to practice this pattern of question. It doesn't mean that exactly these questions will be coming, but you need to practice this pattern of questions. Basically, this pattern of questions is to be asked in your board exam as well as in your competitive exam as well. So I have done few more types are there, which one we will be doing it in the next lectures. Okay, and dear students, don't forget, if you are new to the channel and if you think that this video is helpful to you, don't hesitate to share with your friends. Okay, and don't go without subscribing the channel. Thank you so much.